Hello friends and welcome. The objective of the present module is to discuss canning, its historical milestones, processing steps for canning of foods, different containers used for canning of foods. Let's first see what canning actually is. Canning is a method of preservation in which spoilage can be averted by killing microorganisms through heat. It is generally well known that food carries microorganisms which cause spoilage if left unchecked. These microorganisms are to be eliminated and the entry of other is restricted. In addition, canning allows storing or transporting highly perishable foods in environments where no other preservation method is successful. Canning is defined as the preservation of foods in the sealed containers and usually implies heat treatments as the principal factor in prevention of spoilage. Let's first throw some light on the history of canning. Canning process dates back to the late 18th century in France, when the Emperor Napoleon, concerned about keeping his armies fed, offered a cash award of 12,000 francs to any inventor who could devise a cheap and effective method of preserving large amounts of food. The larger armies of the period required increased and regular supplies of quality food. Limited food availability was among the factors limiting military campaigns to the summer and autumn months. In 1809, Nicolas Appert, a French confectioner and brewer, observed that food cooked inside a jar did not spoil unless the seal is leaked, and developed a method of sealing food in glass jars. Appert was awarded the prize in 1810 by Count Montalivert, a French minister of the interior. Based on Appert's methods of food preservation, the tin can process was allegedly developed by two individuals in England, Brandonkin and Peter Durand. Brandonkin, an associate of John Hall's at his Dartford Iron Works, realized in 1811 that iron containers could be used instead of the fragile glass, and in 1812 the factory began to produce canned food such as meat. In 1810, Peter Durand patented the use of metal containers, which were easier to make and harder to break than glass jars. The glass jars used by Appert frequently broke. He covered iron cans, which were prone to rust, with a thin plating of tin, which is not adversely affected by water, and invented the tin can. By 1813, Durand was selling canned meat to the Royal Navy. Now let's discuss general process of canning foods. The canning process involves pre-treatment of food materials, preparation of cans, filling and closure of the cans, technique of heating the filled cans to kill microorganisms without damage to food materials. Finally, cooling, cleaning and storage of the product. Various steps involved in canning process are sorting, grading, washing, peeling, coring, pitting, slicing and cutting. Firstly, we will discuss sorting. After receiving the raw material at cannery, it is first sorted. For example, damaged or bruised fruits and vegetables are sorted. Only sound fruits and vegetables are used for canning. They are then sorted for size and maturity. Second step is grading. After preliminary sorting, the raw material is graded because the process requirements may differ with different grades. Thus, it is important to obtain a product of uniform quality. Different types of graders used in fruits and vegetables are screen graders, roller graders, rope or cable graders. Third step is washing. One of the important steps in canning is cleaning of raw materials. Running water or high pressure water sprays can be used for washing in case of fruits. After washing, it is peeling, coring, pitting, slicing and cutting. These can be done manually or with machines. Peeling can be done by hand knife or by machines by heating or by hot light treatment using 1 to 2% lye solution or by flame depending upon the nature of raw materials. The fish and meat are cut into small slices and uniform cuts before filling into cans. Another step is blanching. Blanching is done for fruits and vegetables by immersing them in hot water or by exposing them to live stream or hot air for a proper period of time followed by cooling. Microwave blanching can also be used. After blanching, filling is carried out. Empty cans that should be packed carefully by employing the manual labor or through mechanical device. While packing, care should be taken to see that no air pockets are left which can't be removed by exhausting. Next step is syruping and brining. In canning, syrups are added to fruits, whereas brine, that is salt solution, is added to the vegetables. However, in case of fish and meat, hot sauce, oil brine or prepared gravy is used. Purpose of adding syrups or brine or other medium is to improve the flavor, fill the space between the pieces of canned product and aid in the heat transfer during sterilization. The syrup, brine, hot sauce, oil or prepared gravy should be added to the can at a temperature of about 90 degrees Celsius, leaving suitable headspace in the can. After brining and syruping, exhausting is done. Exhausting usually means heating the can and can contents before sealing. Sometimes it may also refer to the treatment of the container under a mechanically produced vacuum, but in other cases, it is done to remove air from the can interior and prevent corrosion. It also prevents undue strains upon the can during sterilization and prevents overfilling of can contents. In heat exhaust method, the cans are generally passed through a tank of hot water at about 90 to 97 degrees Celsius or on a moving belt through a covered steam box. The time of exhaust varies between 5 to 25 minutes. After exhausting, cans are immediately sealed with the help of double rolling operation of seamer. Dear students, let's now discuss processing of the cans. The term processing as used in canning technology means heating of canned foods, that is fruits, vegetables and other foodstuffs, to inactivate bacteria. This is also called as retorting. Processing consists of determining just the temperature and the extent of cooking that would be sufficient to eliminate all possibilities of bacterial growth. In retort, saturated steam is supplied to heat the product. Time-temperature combination of processing depends upon the type and physical state of the product, the heat resistance of microorganisms or enzymes likely to be present in the food, the heating conditions, pH of the food and the size of the can to get complete sterility. In low acid foods, that is having pH greater than 4.5, Clostridium botulinum is the most dangerous heat resistant spore-forming pathogen likely to be present. Now let us discuss rate of heat penetration during processing. Heat is transferred from steam or pressurized water through the container and into the fruit or vegetable or any other canned food. The rate of heat penetration is measured by placing a thermocouple at the thermal center of a container, the point of slowest heating, to record temperatures in the food during processing. The important factors that influence the rate of heat penetration into a food are type of product, liquid or particulate foods, for example, peas in bran, in which natural convection currents are established, heat transfers faster than in solid food in which heat is transferred by conduction, for example, pastes or purees. Number second is size of the container. Heat penetration to the center is faster in small containers than in large containers. Number third is agitation of the container. End over end agitation and to a lesser extent axial agitation increases the effectiveness of natural convection currents and thereby increases the rate of heat penetration in viscous or semi-solid foods, for example, beans in tomato sauce. Fourth one is temperature of the retort. A higher temperature difference between the food and the heating medium causes faster heat penetration. Next is shape of the container. Tall containers promote convection currents in convective heating. Next is type of the container. Heat penetration is faster through metal than through glass or plastics owing to differences in their thermal conductivity. Now finally we will discuss cooling. Immediately after processing, cans are cooled quickly to prevent overcooking and stock burning. Cooling has sterilizing effect by giving thermal shock to thermophilic microorganisms. The processed cans are usually cooled to 37 degrees centigrade so that surface moisture dries out. Now let us discuss testing of defects. After cooling, the cans are tested for leaks or imperfect seals. A simple way of doing this is to tap the top of the can with a short steel rod. A clear ringing sound indicates a perfect seal, while a dull, hollow sound shows a leaky or imperfectly sealed can. Wax at a very high temperature, that is 115.5 degrees Celsius, can also be used to test the cans. The cans containing the product are placed in bath. Any leakage is indicated by bubbles coming out of the wax bath. A vacuum gauge can also be used. A good quality can should have a vacuum not less than 8 inches of mercury. Dear students, now let's discuss labeling and storage. The outer surface of cans is then dried and labeled. The cans should be stored in a cool and dry place. The shelf life of a product differs with nature of canned material. Now, what are the different types of containers that are used for canning? Containers for heat preserved food must be hermetically sealed and airtight to avoid recontamination from environmental microflora. Mostly metal containers are used for canning of foods. However, in some cases, glass jars or aluminum containers are also used. The metal cans or tins are produced from tin plate. They are usually cylindrical. However, other shapes such as rectangular or pear-shaped cans also exist. Tin cans consist of 2 or 3 elements. In the case of 3-piece steel cans, they are composed of the body and 2 ends, that is bottom and lid. The body is made up of a thin steel strip, the smaller ends of which are soldered together to a cylindrical shape. 2-piece steel cans have a lid similar to the 3-piece cans, but the bottom and body consists of one piece, which is molded from a circular flat piece of metal into a cup. These cup-shaped parts may be shallow drawn, that is with shorter side wall, or deep drawn, that's with longer sidewall. The following are the different types of base plates used for can manufacture. First one is type L. It is high purity steel with low metalloid and residual content. This kind of base plate is used for highly acidic foods. Number 2 is type MR. It is a low metalloid steel with no severe restriction on residual content. It is used for moderate acid foods. Number 3 is type MC. It is similar to MR type but has high phosphorus content to give mechanical strength or stiffness. It is usually used for low acid foods. Now let us discuss lacquering. It is difficult to coat steel plate uniformly with tin during the process of manufacture. Small microscopic spaces are always left uncoated, although the coating may appear perfect to the naked eye. The content of the can may react with exposed parts of the container and cause discoloration of the product or corrosion of the tin plate. The process of coating of inner side of the can to prevent discoloration of the product is called as lacquering. Lacquers include oleoresinous material, synthetic resins, phenolic resins, epoxy resins and vinyl resins. There are two types of lacquers. Number first is acid resistant and sulfur resistant. The acid resistant lacquer is ordinarily gold colored enamel and the cans treated with it are called as R enamel cans. The sulfur resistant lacquer is also of golden color and the cans coated with it are called C enamel cans or SR cans. Acid resistant cans are used for packing of foods of the acid group with soluble coloring matter such as raspberry, strawberry, red plum, colored grapes, etc. Sulfur resistant cans are used for non-acid products like peas, corn, beans, meat, fish, etc. This was all about canning. Thank you very much.